Now it's going to be my pleasure, I believe I'm going to go ahead and introduce our speaker, Dr. Malkas. And you know, you feel inadequate when you see all the beautifully dressed people and all the singing, and now I have to read her about Dr. Malkas, and you'll see that she has an extraordinary history. She actually had an extraordinary academic journey, and it all started when, as a child, she determined that she really wanted to be an astronaut. Thankfully for us, she had an epiphany a little bit later on. She received her first degree in engineering and subsequently a BS in chemistry and a PhD and a PhD in biochemistry from the City University of New York. And she was a postdoctoral fellow at the Worcester Foundation for Experimental Biology in Shrewsbury, Massachusetts. She then joined the faculty of the University of Maryland School of Medicine as assistant professor in 1990. And it was while she was at Maryland that she became the first to isolate and characterize a fully functional multi-protein complex from human cells that supports DNA replication in vitro. She then demonstrated that DNA replication apparatus of human breast cancer cells mediates an error-prone DNA synthetic process. She was also able to correlate acquisition of a mutagenic DNA replication mechanism in breast cancer with the modification of a specific protein in the DNA synthetic apparatus. Dr. Malkas is evaluating this protein as a potential biomarker for breast cancer and as a target for cancer therapy. Now, what did I just say? Right. All you need to know, it's good stuff, it's pioneering, and it could really change prevention and treatment of breast cancer for women for years. And I don't think I'm overestimating to say that. In January 2002, Dr. Malkas joined the faculty at the Indiana University School of Medicine as a professor of medicine. It's not easy to be a professor of medicine. Usually you're an assistant for quite a long time. She's a professor of medicine and was named the Vera Bradley Chair for Oncology. In March, Dr. Malkas was named the co-leader of the Indiana University Cancer Center's Hormone and Reproductive Oncology program. In 2006, she was given the additional title of Professor of Surgery. That doesn't seem fair to me. Her scientific reputation is national. She's been invited to participate in a variety of NIH, National Institutes of Health, and Department of Defense grant review study sections, including a number of Department of Defense breast cancer program grant review panels and chairing a DoD ovarian program project review panel. Those are really important positions. I doubt too many other people from Indiana are asked to actually review other people's research, so that's quite an honor as well. She's demonstrated continued academic excellence and a determined passion to positively impact the diagnosis that most women fear the most, breast cancer. Her commitment started for a very personal reason, and I quote, "I got my first look at the horror of cancer when my father died from it in 1984. I don't care if anybody remembers my name, if I can make a few less tears in the world wrought by cancer, and if someone finds through my work something that makes a dent in this disease, then I'll know why I lived." Congratulations on that. That's beautiful. And it's with great admiration I introduce Dr. Malkas.
Hi. After that, well, as she was going on through, I was going, well, I don't need to talk anymore because she just did everything. But anyway, I want to thank you. I am so honored to be here. I can't thank Fort Wayne enough. You know, I'm going to tell you something. Before I became the Vera Bradley Chair, do you know that I never spoke to a group like you ever before? I only spoke to other scientists where I talked about very scientific things, or I talked to family members if they had cancer, but I never spoke to a general audience. And I have to thank Vera Bradley because they didn't know I didn't do that. They just said, hey, would you go over here and go over there and go? And I was like, oh my God. But so I have to thank you all. I can speak, kind of. Now, I'm going to talk. Okay, well, first off, can I have the first slide? Yeah, I'm one of those, you know? So who is this person? I know you read all that stuff, and it sounds it does sound very impressive, you know? So who is this person that's standing right here looking at you, and you looking at me, which is really weird. Trust me, if you were up here, you'd feel really weird. But who is this person? If I could have that next slide. So I'm just Linda from Queens. I always joke that I'm the flashy girl from Flushing, you know? I'm just Linda from Queens. And I was so touched by all the beautiful women up here in their garb tonight, because Queens is like the melting pot of New York City. You either go to Brooklyn or you go to Queens. And I wanted to say that the women were so beautiful. I don't know how all you all felt about it, but I felt like they were all different flowers. And they were just so beautiful. So thank you. But anyway, so that's where I grew up. I actually took the number 7. That's it. And the nice thing I say about Queens is that I get the better view of Manhattan, okay? Whereas, you know, they have to look at Queens, okay? But, because I want you to know me before I go launching into my science gig. So what inspires a little girl of 9 to go and decide she wants to be a scientist? And if I could have the next slide. I, like a whole generation of people who became engineers and scientists, were inspired by going to the moon. Think about that, a concept. We've actually danced. Some of those guys actually danced up there, if you remember. We have walked on the moon. Unimaginable. But that thought, and I talked here earlier to this engineer right here, and he was inspired as well by this. So I had 3 things that inspired me. This was the first. Here is the second. Okay. Okay, I am sincerely a Trekkie if you are insulting me. Okay, oh, hi. Beat me up. So anyway, these were 2 things that came together. So people were going to the moon, and you had Star Trek. And for me, I really thought, I'm going, you know, beam me up, you know. And then there's 2 things. I'm 9 now, and I'm saying, you know, I really want to be a scientist. I want to be an engineer. I want to be an astronaut. And I go to, the next slide, and I go to my parents. And my parents, and I really was touched by what you said about how important parents can be to everyone. And so whether if they're not your proper parents, but I think we as a community have to support our young people. Now my parents, let me tell you a little bit about my parents. I grew up in Queens in a 2-room apartment. It was my parents, my little sister, 2 golden retrievers, and an unhappy landlord, and me. Now, my parents never had the opportunity to go to college. They worked very hard every day. Both my parents went to work. But they were darn sure that their daughters were going to reach really high. And so I'm 9 years old, and I go to my daddy, Tony. And I have to tell you a little bit. Let me just step back. I want to tell you about this picture. I was 7 years old, and I told my dad I wanted a Polaroid camera. Because I saw it like on the TV, you know, it looks so cool. And so for my birthday, he got me a Polaroid camera. But to tell you how financially strapped they were, he couldn't spend the $2 extra to get the color film. So I got my Polaroid camera. This is the back of my uncle's backyard in Flushing, Queens, with my parents. And so I call this my Harry Potter picture, because they are looking at me taking my first picture with a Polaroid. Both of them are gone now. I lost my dad to cancer, and I lost my mom to diabetes. All right? But I like to think that they're both looking down right now going, oh, she's hot. But anyway, so let me get back. So I'm 9 years old, and I go to my dad and my mom, you know, and I'm sitting on Dad's knee. It's almost like the Faith Hill song that she had. And I said, Daddy, I want to be an astronaut. And I mean, like, you know, with my, like, you know, like it's just, and he said, honey, you can be anything you want to be. And that's what you have to gift little people in your life. You can be anything you want to be. Okay, so let's go on to the next thing. Now we get to the science part. I spend a lot of time on airplanes. I really do. And invariably you wind up, somebody sits next to you, and it's usually a guy, and they'll eventually ask you what you do, and I say a cancer researcher, and at that point, without a doubt, I become everyone's best friend. I know more about people who are flying America's skies than probably than anybody. And if it's a guy, I hate to break it to you, they're usually asking me about prostate cancer. Always, you know? But anyway, but then they're very nice, usually very, very, very nice. But one time, I'm sitting next to him in the middle seat. I'm caught in the middle seat. This fellow's in the aisle seat. And he says, what do you do? And I said, I'm a cancer researcher. And he turns to me, and he looks like he's going to pop me in the head. And he said, why isn't there a cure for cancer yet when we have already put men on the moon? And I thought, great, I'm sitting next to him, and I got a 4-hour flight. And I said to him, because it is easier to put men on the moon. Now, to give you a flavor for what I'm saying, because you know, we have spent gazillions of dollars on cancer research. You know, we keep thinking we're waiting for it. I just don't know if you understand just how complicated. It's not like a bacteria. You know, if you have like a bacterial infection, you know, you can take an antibiotic and they can get rid of it because it's other. Cancer really is us. And I want to give you an idea of just how magnificent you are. If I can have the next slide. So, don't worry about this, but you are composed of 50 million cells. You say, what is that? Imagine if you had $50 million. Usually people put it together that way, way faster. It's a lot of cells. Inside of each of your cells, which you can't see, you know, there's something called a nucleus. Don't worry about it. It's in there. This tiny little nucleus inside a cell, and in it is something called DNA. You've heard about it. It looks like a ladder. Don't worry about it. But if I was to take the DNA out of one nucleus, out of one cell, and stretch it out, it would be 3 feet long. Think about that. One nucleus, one DNA complement. If I was to take any one of you, your 50 million cells, and I was to take all the DNA out of your cells, and I was to then put all the DNA of one individual on the floor here, and let her go up, one individual's DNA stretches beyond the sun. And all of that DNA has to be taken care of, protected throughout your lifetime, or what happens? Disease, not just cancer. Isn't that magnificent? You're all sitting there like, well, I'm nobody, I'm depressed and everything else, but you're the most freaking amazing machine that has ever walked the earth, and not likely to be replaced anytime soon, okay? So, that's why it's so complicated to deal with cancer. It really is, because you're so complicated. There are these incredible processes going on that we're only now just starting to figure out. Now, if I could have the next slide. So now I'm going to start my very general, what you need to know about cancer. And if you understand this slide, kinda, you know everything that's going on in cancer. We know that there's a bunch of ways you can transform a cell. We just had a lovely discussion about how that is. Smoking, all kinds of things. We know that a lot of changes happen in cells, so that actually a pathologist using their eye can more or less in a lot of cases pick out cancer. We know that cancer cells are started by DNA damage, but you may not appreciate, but as cancer goes on, it continues to make DNA damage to itself. Hey, here's another fun fact. Everyone in this room is a cancer survivor.